Hi everyone. I want to introduce a new scheduler which name is Hawk. It is a kind of hybrid data center scheduling which is developed by Pamela and Florin in 2015. The purpose is to solve the problem of efficient scheduling of large clusters under high load and heterogeneous workloads. Here I want to explain a little of heterogeneous workload. It is a bunch of jobs which consists of a few long ones and many short ones. According to author's paper, usually the ratio of long jobs is less than 10% of all. They design Hawk to overstep both centralized and distributed schedulers. These two schedulers have their own drawback in opposite directions. Centralized scheduler will be overwhelmed by a very large number of scheduling decisions. It will lead to long latencies. Distributed scheduler is quickly in scheduling, which will be bad sometimes. Hawk stack a middle ground of them. It improves great in scheduling short jobs and performs also well in long ones. As we know, CPU scheduling is the process of determining which process will own a CPU for execution, while another process is not on hold. The main task of CPU scheduling is to make sure that whenever the CPU remains idle, the operating system at least selects one of the processors available in the ready queue for execution. This part's main meaning is getting a high utilization of CPU. There are several specific requirements in CPU scheduling. Usually, people want the tasks to begin as soon as possible. We can say that responding time is short and can be done as soon as possible. Say that turnaround time is short. There are also other targets of CPU scheduling, like high throughput, short waiting time, and so on. In real situations, the style, the length, and the coming time of the tasks are all different. We cannot design a perfect algorithm for any circumstance. So people designed different algorithms to deal with all kinds of tasks and try to get the best solutions. So what is the synthesis of Hawk suitable for? It is mainly in these three parts on this page. Hawk does not deal with a single processor. It is about a large number of processors, which called a cluster in the article. We can know that in the experiments, the authors used a group of servers, which number is 100 according to the paper. Another condition is high load. It is easy to understand by the name. And the last one is heterogeneous workload. I have explained it just now. It is very important, or we can say it is experimental environments. If the workload is not this kind of composition, like a few tasks and many shorts, like a few long tasks and many shorts, the result will be totally different. Actually, we can guess that Hawk will not perform better than Sparrow through its structure. I will talk about its characters in following parts. The purpose that we use large cluster is to deal with big number of jobs. In real world, these jobs usually are in different of size. They also have very different requirements to latency. It is very easy to understand. Some jobs must be in hurry and some can wait for a longer time. This is very normal. Naturally, short ones are latency sensitive. So in the processor group, it needed to solve the responding time and at the same time to reduce idle nodes. Before introducing Hawk, we can have a look at two main styles of schedulers. The first generation cluster scheduler are centralized. Centralized data center schedulers can make high quality placements decisions when scheduling tasks in a cluster. Today, however, high quality placements come at the cost of high latency at scale, which decreases response time for interactive tasks and reduce cluster utilization. Two reasons for these characters. First, making decisions in a single place leads to high quality. Second, high load, which will be higher in future, lead to latency. And distributed scheduling is an approach that enables local decision makers to create schedules that consider local objectives and constraints within the boundaries of overall system objectives. So it is obviously quick, but with the partial information, the decision will not so high quality. And Hawk combines centralized and distributed schedulers, in which the centralized entity is responsible for scheduling long jobs, and short jobs are scheduled in a distributed fashion. The authors call it hybrid. So while the author developed this kind of hybrid cluster scheduler, the motivation is something clear so far. The first, workload heterogeneity becomes normal in current data center. The authors analyzed the public available Google trees, and they also made a table of this kind of workload by different open source, like Google. These facts show that designing a new cluster scheduler is urgent, useful, and meaningful. From this table, we can see that long tasks in all the cases are below 10% of all. It meets the requirement of Hawk. Second, high utilization in data centers. This part is very clear. If people want to reduce the cost, the method is to increase the efficiency. It is the same in the processor cluster. The less idle nodes, the better in the running time. And last, the challenges of high load in distributed scheduling. In fact, we can see high load is a challenge. As we know, distributed schedulers may not have enough information to match incoming jobs to the idle servers. When the jobs increase, this drawback will be more obvious. In spiral simulator with high load, Few servers are idle. The authors use a spiral simulator, but in their own scenario. This scenario is detailed in the article. They found there will be at least 2% of the servers are idle for any incoming sort job. From the motivation we can get, Hawk schedulers' goals are to run the cluster at high utilization, to improve performance for short jobs, which are the most penalized ones in the highly loaded clusters, to sustain or improve the performance for long jobs. How to accomplish these targets? We can talk the whole thing by these aspects on this page. The first thing is the system model. I have talked the tasks style above, a few long and many shorts. The policy of execution in single server is first in, first out. That means no matter what kind of tasks scheduled in this server will be added at the end of queue. Above nutshell of Hawk, I want to give the basic techniques used in the scheduling. Hawk will reserves a small part of cluster for short jobs. That means short jobs have relatively priority. It uses distributed scheduling of short jobs. This is similar as Spiral, but Hawk uses randomized work scheduling to move the first short jobs queued behind long tasks to the idle servers. This step avoids the drawback of Spiral, makes the short jobs responding time improved much, and Hawk uses centralized scheduling on long jobs. The reason is simple. The long jobs are few. They cannot overwhelm the scheduler but perform high quality. This is all the structure of Hawk. However, here lays a problem. How to tell which tasks are short or long? The authors use estimates time instead of average task running time. They compare them to a threshold which is based on statistics of past jobs. If the job's running time is smaller than the cutoff, they can be scheduled in a distributed fashion. After solving the task's length problem, the authors need to split the cluster because they reserve the short jobs by some servers. This guarantees no matter when stealing a short job, it can be processed in a serve, or at least queued in a short line. They used the proportion of time that cluster resources are used by long jobs to divide the cluster. So far, the whole structure of Hawk has built. As we mentioned above, Hawk scheduled short jobs with distributed approach. Each short job has its own scheduler. This part is as same as Spiral does. Hawk's own feature is stealing short jobs, which is queued behind the long jobs. In the paper, they use a random method to achieve the purpose. The authors randomly access the servers. Once find a short job is behind a long one, move it to idle servers. The last technique used in Hawk is schedule long jobs in a centralized scheduler. This part we have talked about. The only thing needed to mention is that the long tasks are queued in a priority queue. Finally, Hawk is implemented as a scheduler plugin for Spark. Spark Scheduler is a core component of Apache Spark that is responsible for scheduling tasks for execution. Besides the introduction of Hawk, the author gave the results of experiments. They mainly compare Hawk to Sparrow. They also have some results between Hawk and the centralized scheduler. At the beginning of any experiment, it will give the basic information of methodology. Hawk is not expression. This basic information includes workloads, simulator, and so on, which are on the page. The workloads come from Google 2011, which contains 506,460 jobs. Cloudera C 2011, Facebook 2010, and Yahoo 2011. The authors give a table of the workloads, and the ratio of long jobs meets the Hawk's requirement. They augment the event-based simulator used to evaluate Sparrow. Cluster fact is that 100 nodes with 1 centralized and 10 distributed schedulers. The parameters has also mentioned above. A node performs task stealing by randomly contacting 10 other nodes and stealing from the first node that has short tasks eligible for stealing. For metrics, they take the ratio of 50th or 90th job runtime for both. Overall results on Google Trace and other additional traces. In the best cases, Hawk improves the 50th and 90th percentile runtimes by 80% and 90% for short jobs, and by 35% and 10% for long jobs. Hawk improves the short jobs runtime at 90th percentile more than at the 50th percentile. In the Facebook, Cloudera, and Yahoo traces, the short partition is less utilized compared to the Google trace, so there are more chances for stealing. The author also compared Hawk to fully centralized approach and to split cluster. For long jobs, the centralized approach performs slightly better because they can use the entire cluster. In Hawk, they only use the general partition. But for short, Hawk performs much better. Here are some scheduling methods which are related with the author's work. They are first and second generation scheduler: Sparrow, Apollo, Mercury, Omega, HPC, and Grid. The most important one is Sparrow. Sparrow is a fully distributed scheduler that performs well for lightly and medium loaded clusters. Hawk is very similar with Sparrow. Even we can see Hawk is a combination of centralized scheduling and improved Sparrow by dealing with high load jobs through the technique of stealing short jobs. At last, the authors get the conclusion. Hawk schedules only the long jobs in a centralized manner, while performing distributed scheduling for the short jobs. Hawk outperforms Sparrow, a state-of-the-art, fully distributed scheduler, especially in the challenging scenario of highly loaded clusters. Hawk make a big progress in dealing with short jobs, and does slightly well in long jobs. Thank you for hearing my introduction of Hawk.